Here are two protons. We know that the electrostatic force between them causes them to repel. So why doesn't the nucleus of an atom fly apart? The answer to this question is the residual strong force. To understand this force, we'll need to explore quantum particles like quarks, gluons, and mesons. Let's start by looking at a proton and a neutron, particles which are collectively called nucleons. Each nucleon is made up of 3 quarks. Similarly, antinucleons, which make up antimatter, are each made up of 3 antiquarks. In addition to electric charge, quarks and antiquarks have another type of charge, which physicists have dubbed color charge, even though it has nothing to do with actual colors. Each quark can have a color charge of red, blue, or green, while each antiquark can have a color charge of anti-red, anti-blue, or anti-green. A key property here is the conservation of color charge. Essentially, quarks cannot be isolated. They must exist in systems where the colors cancel out, as in these 5 combinations. Gluons are particles that carry both color charge and anticolor. They ensure the conservation of color charge in a nucleon by controlling interactions between quarks. For example, a green quark may emit a green anti-blue gluon, which is absorbed by the blue quark, turning the green quark blue and the blue quark green, ensuring that the whole quark-gluon system remains colorless. In this way, gluons are constantly exchanged to conserve the color charge between quarks in a nucleon, forming a gluon flux tube. These interactions mediate the strong force, a fundamental force of nature that holds together the quarks in a nucleon. The gluon flux tube is like a rubber band. The further you stretch it, the greater the force. But sometimes, this rubber band breaks, releasing its stored potential energy, and by Einstein's E=mc², mass, creating a quark-antiquark pair, known as a meson. Going back to our nucleon, it's important to recognize that the interactions between quarks are not perfect, and quantum fluctuations can create momentary imbalances of color charge. Mesons mediate these imbalances through the residual strong force, an incredibly strong force that acts over short distances in the nucleus, without which our universe would have no elements more complicated than hydrogen, and we would cease to exist.